So continuing with matrix multiplication questions, here I have a question. It says find x, or they could say solve if 1x multiplied with a 3 by 3 matrix here into another 3 by 1 matrix is equal to 0. So it's the product of 1, 2, 3 matrices. So what I have to do is I just have to perform the multiplication on the left side and equate it with 0 means 0 matrix on the right side, because the left hand side is a matrix, the right hand side is also a matrix. So this 0 is actually 0 matrix. It stands for this 0 matrix, the letter O actually it is. Okay, so that's a 0 matrix. So I'm going to do this multiplication, and so I will multiply the first two matrix. This is it has got only one row, but it has got 3 columns, and this has got 3 rows and 3 columns. So I'm going to multiply those two matrices first, and I'm checking the order. It's a 1 by 3 matrix. The first one is 1 row and 3 columns. So a 1 by 3 matrix is being multiplied by a 3 by 3 matrix. 1 by 3 matrix into a 3 by 3 matrix, and we need to make sure that the middle two numbers are always the same. Then only you will be able to do matrix multiplication. The middle numbers are same. So the product would be, you cancel out those two, and the product would be a 1 by 3 matrix, the remaining numbers 1 by 3 matrix. So when I multiply these two matrices, the answer is going to be a 1 by 3 matrix, which means it will have 1 row and 3 columns. So I always keep this arrow mark like that. The first row gets multiplied with the first column to give me the first element, then first row goes with the second column, then first row goes with the third column. That's how I multiply. It has got 1 row and 3 columns. So I take my first row and multiply along the first column. So 1 into 1 plus 1 into 0 plus x into 2. So that's what I'm going to write there. So 1 into 1 is 1 plus 1 into 0 is 0 plus x into 2 is 2x. Now again I multiply the first row with the second column. So when I multiply the first row with the second column, 1 into 0, 1 into 0 is 0, then 1 into 2 is 2, and x into 1 is x. So this first row with the second column. Now finally the first row with the third column. So 1 into 2 is 2 plus 1 into 1 is 1 plus x into 0 is 0. And I'll copy this third matrix because we haven't touched that matrix. So I'll copy that as it is equal to 0 matrix. I need to do the little bit of simplification here. So I will rewrite it 1 plus 2x. This is 2 plus x, and that is 3, just 3. 2 plus 1 is 3 into, I still have 1, 1, 1 is equal to 0. Now I need to do the multiplication of these two matrices, but I won't multiply without checking the order. This is 1 row, but it has got 3 columns. So I'll write it's a 1 by 3 matrix, which is being multiplied by this matrix has got 3 rows. Horizontally there are 3 steps. 1, then there is second row, and then there is third row. So first, rather the other way around, first row, the second row, and the third row. There are horizontally I can count 3 times like that. So it is 3 rows, 1, 2, 3, 3 rows, but only 1 column. Here 1 row, but there are 3 columns, 1, 2, and 3. So 1 by 3 matrix multiplied by 3 by 1 matrix. The middle numbers are same, you cancel them out. So the answer is going to be a 1 by 1 matrix, which means 1 row, 1 column. That means one single element is what I am going to get out of this. So I'll put the arrow marks to show how I am multiplying. The first row goes with the first column, and that's it. I don't have any other column. So 1 plus 2x into 1 would be 1 plus 2x plus, there is no space here, it's plus, because the first element with the first element plus, the second element with the second element plus, the third element with the third element. The first row multiplied with the first column, 1 plus 2x into 1 plus 2 plus x into 1 plus 3 into 1 is 3 is equal to 0. This on simplification is 2x plus 1x is 3x, and 1 plus 2, 3 plus 3 is 6. So 3x plus 6 is equal to 0, 0 matrix. In fact, 0 is 0 matrix. That's how I wrote it this way. And if two matrices are equal, their corresponding elements are equal. So I skip the bracket, I skip the matrix symbol, and I write 3x plus 6 is equal to 0 because two matrices are equal. So their corresponding elements are equal, and there is only one element inside. So 3x plus 6 is equal to 0. So 3x is equal to minus 6, x is equal to minus 6 divided by 3, which is minus 2. So that's your answer, and you have a question for you to try on your own. So you should pause the video, copy the question, and do it yourself. So you have another question here. Find x if x for 1 into that matrix over there into x for 1 is equal to 0. So product of three matrices is equal to 0 is what I have there. It's almost the same question as what we did before. So we're going to check the order of the first two matrices so that we will be able to multiply them. The first matrix has got only one row, but there are three columns. So 1 by 3 matrix multiplied by this one is a 3 by 3 matrix. The middle numbers are same, so you cancel them out. So the answer will be a 1 by 3 matrix. The answer is going to be a 1 by 3 matrix. So let's do that multiplication between the first two matrices. The first row with the first column. So x into 2 is 2x plus 4 into 1 is 4 plus 1 into 0 is 0. That's first row with the first column. Now first row will go with the second column. How would you do that? X into 1 is x plus 4 into 0 is 0 plus 1 into 2 is 2. So that is first row with the second column. X into 1 is x, 1x plus 4 into 0 is 0 plus 1 into 2 is 2. And then I have again the first row with the third column. So x into 0 is 0 plus 4 into 2 is 8 plus 1 into 4 is 4. Okay, that's the product of the first two matrices, a 1 by 3 matrix, 1 row and 3 columns. Into the next matrix, x for 1 still stays there is equal to 0 matrix. I'm going to perform this multiplication. It's like that. This row will go along the column. It's a 1 by 3 matrix multiplied by a 3 by 1 matrix. My answer has to be a 1 by 1 matrix. So I just copied that one more time. So 2x plus 4, this is x plus 2, that's 8 plus 4 is 12 into x for 1. So it's basically the same thing, I just copied it again. And then I check the order. Order is going to be a 1 by 3 matrix multiplied by a 3 by 1 matrix. So the answer has to be a 1 by 1 matrix. So 2x plus 4 into x, that's going to be 2x squared plus 4x. 2x plus 4 into x is 2x squared plus 4x plus x plus 2 into 4 will make it 4x plus 8. X plus 2 into 4, so 4x plus 8. Then plus 12 into 1 is plus 12 is equal to 0. And this on simplification will be 2x square plus 4x is 8x plus 20 is equal to 0. And of course, I didn't put the matrix symbol because if two matrices, the right hand side is a 0 matrix, which means every single element inside is 0. Left hand side, I have a matrix, right hand side, I have a matrix, so the corresponding elements are equal. So I just equated them. I can divide throughout by 2, so I get x squared plus 4x plus 10 is equal to 0, which is a quadratic. And I first try to get product as 10 and sum 4. Product 10, either 1 into 10 or 2 into 5. There is no other possible combination. And I can't get 4 out of any of those combinations. So that means splitting the middle term doesn't work. So I need to use the quadratic formula. So this is the quadratic formula, minus b plus or minus root of b square minus 4ac by 2a. You plug in the values and try to simplify, and when you try to simplify, you are going to get 16 minus 40, which is root of negative 24 by 2. So we say that doesn't exist. It's not a real number, root of a negative number. So there is no solution to this question. So pause the video and write it down. So another question here for you to try. make sure that you check the order before you actually do the multiplication. We have another question. If A is equal to cos x is cos alpha sin alpha minus sin alpha cos alpha, show that A square is equal to this. So I'm going to start with A square. A square means A into A in matrices. It's not squaring of individual terms. A square means multiply A 2 times. So I will write the matrix 2 times, and it's going to be a 2 by 2 matrix, 2 rows and 2 columns. 2 by 2 matrix into another 2 by 2 matrix. Middle numbers are same. The remaining numbers are again 2 by 2. So the answer is also going to be a 2 by 2 matrix. So let's multiply. I have marked the first row and the first column so that you won't forget the way you multiply. The first row goes with the first column, then first row goes with the second column. Then we repeat the same thing with the second row. So let's multiply. When I multiply, first row goes with the first column. Cos alpha into cos alpha, cos square alpha, plus sin alpha into minus sin alpha, minus sin square alpha. So that's my first row, first column element. Now first row goes with the second column. Cos alpha into sin alpha cos alpha, sin alpha cos alpha, or cos alpha sin alpha, plus sin alpha into cos alpha, again sin alpha cos alpha. So the first row goes with the second column. Cos alpha into sin alpha plus sin alpha into cos alpha. Now the second row into the first column. Minus sin alpha into cos alpha minus sin alpha cos alpha, plus cos alpha into minus sin alpha cos alpha. One more time. The second row with the first column. Minus sin alpha into cos alpha plus cos alpha into minus sin alpha cos alpha. Now again second row into the second column. Minus sin alpha into sin alpha is minus sin square alpha, plus cos alpha into cos alpha is cos square alpha. And we try to simplify this. Cos square alpha minus sin square alpha is cos 2 alpha. Sin alpha cos alpha plus sin alpha cos alpha is 2 sin alpha cos alpha. Minus sin alpha cos alpha and minus sin alpha cos alpha again is minus 2 sin alpha cos alpha. This is cos square alpha minus sin square alpha has a formula cos 2 alpha. So here I had cos square alpha minus sin square alpha, which is cos 2 alpha, double angle formula. This is the same thing again, cos square alpha minus sin square alpha is cos 2 alpha. At the same time, what I simplified here, 2 sin alpha cos alpha will turn out to be sin 2 alpha, which will give me my answer. So cos 2 alpha, then this turns out to be sin 2 alpha. The next element has a minus sign, but it's sin 2 alpha, and the next one is cos 2 alpha. So that is the right hand side. This is just to evaluate, find the value of this product. Just find the product, that's the meaning. So this kind of a multiplication we already did. Let's check the order of the first two. The first one is 1 row and 3 columns into a 3 by 3 matrix. Should give me 1 row and 3 columns, 1 by 3 matrix. So I'm going to put arrow marks like that so that I don't forget the order. So I'm going to multiply those two. So when I multiply, the first row goes with the first column. 1 into 1 is 1, plus 3 into 2 is 6, plus 5 into 0 is 0. First row into the first column I finished. Now first row into the second column. 1 into 0 is 0, 3 into 0 is 0, and 5 into 1 is 5. Now I have first row into the third column. 1 into 3 is 3, plus 3 into 1 is 3, plus 5 into 2 is 10. And of course, the next matrix 1, 4, 6 would stay as it is. Let's do a bit of simplification here, the addition there. So that's going to be 7, that's 5, and this is 3 plus 3, 6 plus 10 is 16 into 1, 4, 6. Now these two when you multiply, check the order. Check the order. It's 1 row but 3 columns, while second one is 1, 2, 3. Horizontally 3, vertically only 1. So that's a 3 by 1 matrix. So this is a 1 by 3 matrix, this is a 3 by 1 matrix. The middle numbers are same, so you cancel them out. The remaining is 1 by 1. So the answer is going to be a 1 by 1 matrix, which means just one single element inside. and I put the arrow marks like that. So the first row goes with the first column, and that's it, one single element. So multiply 7 into 1 is 7, plus 5 into 4 is 20, plus 16 into 6 is 96, and add it up. That's your answer. You have a question to try on your own. Pause the video, copy down, and do it. If a is equal to 0 minus tan alpha by 2, tan alpha by 2 0, then prove that I plus a, I is an identity matrix. Since my A is a 2 by 2 matrix, I know that this I has to be 2 by 2 as well. So my I in this case is 1 0 0 1, and I need to prove this result. So there is a left side, there is a right side. What we are going to do here is we will work out the left side, get the answer, then we will copy the RHS and then simplify that as well, show that both left hand side and right hand side gives me the same answer. So I am going to start with the left hand side. It's a little difficult, little long, and so it's important as well. So when you look at the left hand side, it is I plus A, and I already figured out that my I has to be 2 by 2 because your A is 2 by 2. So I'll write my I identity matrix 1 0 0 1 plus A matrix is 0 minus tan alpha by 2, tan alpha by 2 0, and we are going to add it. How do we add two matrices? We just add the corresponding elements. So 1 plus 0 is 1, 0 plus minus tan alpha by 2 is minus tan alpha by 2, 0 plus tan alpha by 2 is tan alpha by 2, and 1 plus 0 is 1. That's my I plus A. I'm going to copy the RHS. The RHS is I minus A into that 2 by 2 matrix, cos alpha minus sin alpha, cos alpha. This I minus A, I don't want to do in so much in detail now because I have my I plus A. I'm just going to look at my I plus A, read this plus as minus there, and I can work it out. Just read this as minus there, and then I'll get my I minus A. So that's what I'm going to try and do it. This is 1 minus 0, which is 1. 0 minus tan alpha by 2, minus minus is plus tan alpha by 2. 0 minus tan alpha by 2. So this element is minus tan alpha by 2. And 1 minus 0 is 1. So what I did is, this is actually plus there, but my question is I minus A. So I just read this as minus sign, distributed the minus. Say like 1 minus 0 is 1, 0 minus tan alpha by 2 is tan alpha by 2, 0 minus tan alpha by 2 is minus tan alpha by 2, 1 minus 0 is 1. So I did my I minus A already here, looking at the previous step where I had I plus A. So I worked out my I minus A and I copy the second matrix as it is. Okay, now what I am going to do is I am going to discuss something else. In my first matrix I have tan alpha by 2, so I would like to get everything in terms of tan alpha by 2 even in the second matrix. So in the second matrix I have sin alpha and cos alpha. So I am going to write that formula. We know this formula. Cos alpha is 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. So that's a formula which we have learned in grade 11. Cos alpha, half angle formula for cos alpha. And what I am going to say is, let this tan alpha by 2 be denoted by the letter T. I make a substitution so that my writing becomes easier. It's a huge expression. So I am going to replace tan alpha by 2 everywhere by T. So this would look like 1 minus T square by 1 plus T square. So I have a value for cos alpha as 1 minus T square by 1 plus T square. Now I got to find out what is the corresponding value for sin alpha. So I am going to say there also sin alpha is 2 tan alpha by 2 by 1 plus tan square alpha by 2. That's a formula from grade 11 as well. Sin alpha half angle formula is 2 sin alpha by 2 by 1 plus tan square alpha by 2. But I use the same substitution again. I'll say let tan alpha by 2 be equal to T. So this is going to be 2T divided by 1 plus T square. So I have a value for cos alpha, 1 minus T square by 1 plus T square. I have a value for sin alpha, 2T divided by 1 plus T square. So I'm going to substitute these values into my RHS, which I have reached here. This first matrix is already in tan alpha by 2, which I'll copy as it is, but into the second part I will put the values which I have found now for cos alpha and sin alpha. So it's going to look big now. But the thing is, what I have done is that I am going to replace even this tan alpha by 2 by t, because I said let tan alpha by 2 be t. So when I copied my first matrix here, 1 tan alpha by 2, I wrote it as 1 t minus tan alpha by 2 minus t and 1. So 1 t minus t 1. And then into the next bracket, the next matrix, cos alpha, 1 minus t square. So in place of this cos alpha, I'll put this value. So I'm going to get 1 minus t square by 1 plus t. And then I have minus sin alpha. Sin alpha value I know, so I put that with the minus sign, of course. It's minus sin alpha. So minus, then put the value of sin alpha, which is 2t divided by 1 plus t square. Also down there, sin alpha, I copy that value. And then I have cos alpha, I copy that value. So that's my left hand side, which is pretty big expression now. But I also notice something. Let me rewrite that one more time. So this is what I have. But in this expression here, as I am writing, I notice that the second matrix has a 1 by 1 plus t square common everywhere. So if it is common, why not bring that out? So I am taking that 1 by 1 plus t square common out of the second matrix, and when I bring that out, balance would be whatever I get there, whatever I have in the numerator will be balanced. But before that, I want to copy the first matrix, which is 1t minus t1. I copied it. Here 1 by 1 plus t square is taken out, so you have 1 minus t square. 1 by 1 plus t square is gone, so minus 2t. 1 by 1 plus t square is gone, so 2t. 1 by 1 plus t square is gone, so 1 minus t square. So the common factor we took and kept it outside. Now these two matrices both are 2 by 2. A 2 by 2 matrix multiplied by a 2 by 2 matrix should give me a 2 by 2 matrix. So I'm going to do that multiplication. Of course, keeping 1 by 1 plus t square outside, I put the arrow marks not to forget the order. So first row with the first column, 1 into 1 minus t square, 1 minus t square, plus t into 2t is 2t square. That's first row into the first column. Now the first row into the second column, first row into the second column. So 1 into minus 2t is 2t plus t into 1 minus t square. T into 1 is t into 1 minus t square. So I need to multiply both the terms with t. So t into 1 is t and t into minus t square is minus t cubed. So that's the first row into the first column and first row into the second column. Now the second row into the first column. So you got to do this carefully. Minus t into 1 minus t square. So when I do that, both the terms will get multiplied by minus t. Minus t into 1 is minus t. Minus t into minus t square is plus t cubed. Plus 1 into 2t is 2t. Again, second row into the second column. Minus t into minus 2t will be positive t 2t square. Minus t into minus 2t, positive 2t squared, plus 1 into 1 minus t square is 1 minus t square. Do a little bit of simplification there. So 1 by 1 plus t square would stay there. Here there is a bit of simplification. 2t square minus t square is plus t square. So 1 plus t square. Here minus 2t and plus t will give me minus t and minus t cubed. Here minus t and plus 2t would give me plus t and plus t cubed would stay there. 1 plus 2t square minus t square is t square. So this is what I have here, but I can see that that's going to give me 1 plus t square as a common factor. So I'm going to show that step. This is 1 into 1 plus t square. Isn't this minus t common factor into 1 plus t square? This is a t common factor, t into 1 plus t square. This is 1 into 1 plus t square. So I made everywhere this common factor 1 plus t square so that it can come out now. So 1 plus t square comes out from the matrix divided by 1 plus t square, which I already have there. the balance. If 1 plus t square is gone, I have 1 there, I have minus t there, I have t here, and I have 1 here. And these two will now cancel off. So what I have is 1 minus t. But instead of t, now I write minus tan alpha by 2. Instead of t, I write tan alpha by 2. So 1, outside terms got cancelled. 1 minus, instead of t, I wrote tan alpha by 2. Instead of t again, I write tan alpha by 2 and 1. Which you will see that is the same as what I had on left hand side. So my LHS and RHS are equal. Hence, we proved.